Hello students, in this session let us learn how aggregate blending will be done using trial and error method. Let us first look into the various steps involved for aggregate blending using trial and error method. So before we start aggregate gradation, we have to procure the materials of various sizes. And then, as a first step, we need to determine the gradation of each and every material that is required to be blended. And in the second step, we have to select the target value for the trial blend. So now these target values can be obtained by the design limit specification. So these design limit specification can be obtained by IRC recommendation, or we can also follow MORTH specification to get the design limit or specification. Using these design limit and specification, we can select what is the target value. And in the third step, we have to estimate the proportion. For example, we are having two aggregates, that is aggregate 1 and aggregate 2, which is required to be blend to obtain the required gradation. In the third step, what we have to do is we have to approximately take the 1% of aggregate A and percentage of aggregate B. If we blend those two together, we must achieve the required gradation. For example, here we can take a 30% of aggregate 1 and 70% of aggregate 2 in the first trial. And in the third step, we have taken 30% of the aggregate 1 and 75 or 70% of the aggregate 2. The material is mixed in such proportion, and we have to calculate, we have to find out the combined gradation. So here, and to obtain the and add those together for the gradation obtained for the what will be the combined gradation we will get. So combined gradation is nothing but what will be the target gradation that we obtain when you mix 30% of the aggregate 1 and 70% of the aggregate 2, which we have considered in the third step. So in the final step, we have to compare the results what we have obtained in the step 3 with the target value which we have taken in the step 2. Okay, so now, and we have after the completion of the first trial, we have to compare these two results, and we have to check that whether the uh, results what we have obtained, that is nothing but the combined gradation what we have obtained, that is almost or nearer to equal to the target value. If this value doesn't match, then based upon the experience which you have gained from the step 3, you have to modify with the proportion of aggregate A and B, okay, suitably, such that we will get the target value equal to the combined gradation. We'll take up one example and we will work out how the aggregate blending can be done using the trial and error method. So now, before moving to the example, so let us see some of the requirements of aggregate blending using the trial and method. So here we should have a blending worksheet. So for a blending worksheet involves, so first in the first column we have to consider the sieve size, because the after the results what we have done, what we get after the gradation is done, that has to be tabulated here. For an example, I have three aggregates that does need to be blended. So here if I mix aggregate A, aggregate B and aggregate C, that need to be blended. So here, after doing the sieve analysis or obtaining the gradation, we need to write down what is a percentage pass of aggregate A under the taken C. Similarly, we have to write the percentage pass for the aggregate B and aggregate C. Okay, and next we have to choose a proportion. So how do you choose? Maybe I can take percentage of aggregate as 50%, percentage of aggregate B as 30%, and aggregate C as 20%. So whatever the percentage or trial proportion we have considered, that need to be written here, and then we'll continue with the calculation. So now on simple calculation, if I have taken the percentage blend as a 50%, so next is when I convert it, so what we have to do is 50% is equivalent to 0.5. Okay, I'm just converting the percentage into the decimal value. Okay, so this we use it in the next steps in the calculation. Okay, just to keep this in mind. So here we are not taking the when we do the calculation, the percentage is not taken directly. Instead of it, we will convert into the decimal value. 50% is equivalent to 0.5, 30% is taken as 0.3, and 20% is taken as the 0.2. So in the previous blend sheet, aggregate blending sheet, here the aggregate C is not available. Let us now work out one example. So here the problem statement, so that is required to blend two aggregate. We just have two aggregate. So here you can add as many columns depending upon how many number of aggregates that we are having. So here we have just having the two aggregate and one, and so here the in the third aggregate 3, we can leave that column empty. Okay, so they have given what is a percentage pass. After doing the sieve analysis, the gradation is given for aggregate 2 and aggregate 1. So for example, here the sieve size are given in the inch. Okay, aggregate percentage pass to the 3 by 4 inch sieve is 100%, half inch sieve is 100%, 3 by 8 is 98%, and number 8 is 52. And similarly for aggregate 2 also, percentage of pass through the various sieve is given, and also they have given the design range. So this is what is required for us. When we mix two aggregates A and B, okay, we must obtain a combined gradation which must be equal to these design range. Okay, so now this is the first step. We have obtained the aggregate gradation of two aggregates A and B is available with us, and we are also having the design rate. And next is we need to fix up the target value. How do we take the target value? Target value is usually considered as midpoint of these two values. For example, for this target value, I can take it as 100, and for these two in between 95 to 100, we can consider the target value as 98. Similarly, for sieve range, you can consider the mid-range value of that, and you can choose the what is the target range. And after obtaining the target value is ready with us, next we need to move on to the third step. In the third step, we need to consider what is the proportion of aggregate 1 and aggregate 2 has to be mixed together such that we will obtain this target value. So in the first in the first trial, we have considered percentage of aggregate of 50% and aggregate 2 is 50%. That means to say that we are to get the target value, we are combining 50% of aggregate 1 and 50% of the aggregate 2. Okay, so now using these two proportion 50% 50% each, we need to require what is a percentage blend. So now the percentage blend can be obtained by multiplying the percentage pass with the proportion that we have taken. So now here we have to note proportion, we are not taking it directly. 50% to obtain the percentage blend. So all these value has to be multiplied with 100 is multiplied with the decimal value 0.5. Here also multiply it with 0.5. So these values, the percentage pass, what values you are having, we have to multiply the entire value with the 0.5. And similarly to get the percentage blend for aggregate 2, so all the values under the percentage pass for aggregate 2, that must also be need to be multiplied by 0.5. So why 0.5? We have taken 50% each for aggregate 2, 1 and 2 individually, and if we convert the 50% to decimal value, we get it as the 0.5. So now the what we have discussed earlier, the same thing is being tabulated here. So now you can see here, for we have 3 by 3 4 inch sieve, half inch sieve, and 3 by 8 inch, number 8, and also we have the values under the number 200 sieve. So the percentage pass of all these aggregate is multiplied by 0.5, and we have obtained the percentage blend, as 50, 50, 47, 26 and 3.6 percentage respectively. Similarly, we have done it for the aggregate too. So all these values under the percentage pass is multiplied with the decimal value 0.5 to get the percentage blend. So once we obtain the percentage blend for aggregate 1 and 2, we have to determine what is a total blend, or we can also call this as the combined gradation. So then now in the next step, we have to compare the value of combined gradation, what we have obtained by blending two aggregates 1 and 2 in the ratio 50% 50 percentage each. So we have got for 3 by 4 inch C, total blend is 100, target value is 100, so this is fine. And for half inch C, the total blend what we have obtained is 97, but the target value is 98, so almost near to each other, that is also accepted. But if you see in the 3 by 8 inch C, the target value is 88 percentage and total blend what we have obtained is just 80 percentage. We have a lot of gap there, not accepted. And for in the number 8 sieve also the variation is too much, and similarly in the 200 sieve once again the variation is there, which is not accepted. So now by blending aggregate 1, we can conclude that by blending aggregate 1 and 2 in the proportion 50-50 each, so here we are not able to get the combined blend which is equal to the target value. So these proportions are rejected now. Now in the next step we have to work out with the new proportion. So now here our deviation has started from the sieve size 3 by 8. Now instead of doing the calculation for all the sieve, first what I'll do is we have to adjust the values for the 3 by 8 sieves. If you adjust for one sieve and then we check it for the other sieve, we can obtain the target. Note that for 3 by 8 sieve, the percentage pass for percentage for aggregate A is 94 and percentage pass for aggregate B is 6. So now in the next trial, instead of doing the calculation for all the sieve size, what we are doing is we are taking any one sieve and we are checking out if you mix two aggregates in what proportion we can obtain the desired gradation. So we'll see how it can be worked out. First is we have taken the number sieve 8, so which are not close to the target value, so we have to do the adjustment one. As in the trial 1, we have already considered 50% of the aggregate 1 and 2. So in the subsequent trial, we have to work out, see here in the trial 2, you can see the percentage of aggregate 1 is 55, 2 is 45, in the trial 3 60, 40, 70, 30, 75, 25. Okay, but if you see here since trial 6, we have considered lesser proportion of aggregate 1 and aggregate 2. We have to work out when all the combination. Okay, so now these are all the 7 different proportion we have considered. It is only for 3 by 8 sieves. Okay, we are working out for one sieve, and whichever value comes to closer in this particular step, we will check that particular proportion for all other sieve. So here next we have, and these two values 94 and 65, that has to be entered in the column percentage pass, and then we have to obtain the percentage blend. So how do you obtain the percentage blend? In the trial 1 it is 50-50 percentage, 50 percentage of the 97, that is 47. In the trial 2 aggregate 55 percentage of 94. Trial 3 60 percentage of 94 percentage. Similarly, we have to do calculated for all other trials. Now for aggregate 2, percentage pass is 65 percentage. So now the 65, all these values has to be multiplied with the proportions that I have considered for the aggregate clue 2, that is 50, 45, 40, 30, 25, 55 and 60 percentage respectively. After calculating the percentage blend, we need to determine the total blend. So how do you obtain the total blend? Total blend will be obtained by adding the percentage blend of aggregate 1 and percentage blend of aggregate 2. So that is 47 plus 35 will be equal to 80%. Similarly, for all the trials, we need to calculate the what is the total blend. And next step, we have to compare the total blend with the target value. So here in the first trial, total blend is obtained is 88, but target values required is 88. Lot of variation. And similarly, if you check here with the trial 5, the trial 5, what we have obtained, the target value is 88 and total blend obtained is close to the target value, that is 87% compared to the all other trial. So now we can freeze that trial 5. If you checked in the trial 5, what is the proportion that you have considered? We have considered 75% of aggregate 1 and 25% of the aggregate 2. Okay, so now keeping these two proportion, we have to check for all aggregate A and 75%, 25% of the sieves. So now it is like repetition of the third step what we have done, but it is in the second trial we are repeating the third step. So we have earlier in the third step we have considered 50% of aggregate A and 50% of aggregate B. Now the new proportion based upon the trials we have done, we need to consider 75% of the aggregate B. So now using these two new proportion, calculate what is the percentage of blend and find out what is the total blend. Then compare the total blend or combined gradation obtained with the target value. So now you can check that all the values are close, the total blend what you have calculated is close to the target value. So now we can conclude that by mixing aggregate A with 75% and aggregate B with the 25%, we are able to get the target values. Using the trial and error method, we can get the satisfactory results, but the major drawback here, it involves lot of computations. We have to do so many trials to obtain the required gradation. And also, if we are having just one or two aggregate, 2 to 3 aggregate, the blending of aggregate with the trial and error method will be easy. But if you want to mix more number of aggregates, the time taken for calculation will be more, and also there will be a lot of error that are involved. But if you use some computer programmings, the calculation of trial and error method will be easy. But this particular method is not very commonly used these days. With this, I'll end up this session, and in the next session, we'll see how the aggregate blending will be done by using the other methods. Thank you. Hello students, in this session, let us learn how aggregate blending will be done using trial and error method.